All right. Hey, everybody. I'm Sameen. How's everybody doing? Can everyone hear me? Okay, cool. Cool. So just quick background about me before I get started. Studied CS in school many years ago. Actually dropped out to do a startup, which is what brought me over to the East Coast. After that company got acquired, worked for the acquirer and a number of other companies in sort of engineering and product roles. And now I'm one of the co-founders of Flisk, and throughout the whole time in the past couple decades, I guess, of working in product engineering, focused on primarily data, either building data products, like products that provided data to companies, or working with it internally. So before I get started, I'm just curious, just show of hands, how many of you are familiar with tools like Segment, Mixpanel, Google Analytics? Okay, awesome. That's a good amount. Now, how many of you actually liked working with it, especially as an engineer? Okay, all right. You're in the right place. Cool. So, for those of you who aren't familiar, by the way, basically these tools are called like product analytics platforms. Sometimes they're called CDPs or customer data platforms. But the concept is all essentially the same. What you do is you want to use these platforms to collect data about user interactions, product usage, and you basically sort of all throughout your code base you have these track calls everywhere. And you use it to track data about how effective your product is, what kind of ROI are you getting on your marketing, any number of things. But what I have found in my experience as both an engineer and as a PM, there's really two things that always seem to happen. One, writing this code is just so annoying. Like, it's not that it's hard, because it really is like one line of code. It's not like it's, rocket science, but it's the crazy back and forth, because you end up with this insane game of telephone where it's like, well, okay, I gotta talk to the PM, I gotta talk to the marketer, well, what about the CFO? Well, they define revenue this way. And actually, well, we need to make sure that, the user is verified in this platform before we track it. And before you know it, what should have been extra small ticket that should have taken you 30 minutes has dragged on for 2 weeks. And that single line of code that the PM told you was going to be very simple ends up not being that simple. And then after you do all of that work, the worst part of it is that no one even knows what that data means. Okay, so you've tracked user registration. Well, is it, after someone has submitted their credit card? What about before? You have this field for revenue. Does it include taxes or shipping? There's all this nuance that goes into it, which is understandable, but where does this information live? And at Flisk, that's one of the things we're hoping to solve, is give you an AI that takes care of all this boring but very much essential stuff. And it starts with everybody's favorite topic, documentation. So I don't know if any of you have been through this exercise with your product teams or anything like that, but it's called a tracking plan sheet. And it's basically where you get all the engineers and product managers together for a week or two, and you're like, hey, we're going to grep through the whole code base. We're going to find all these trackers and loggers. And as you can imagine, A, it's really cumbersome. It takes a ton of time. And B, it's probably out of date by the next week, because as soon as a new feature is released or there's any changes to the code base, it's out of date. So what we built is an open source tool to help you with just that. So let's see if this works. All right. So what we've got is this command line tool. You point out your repo. We support Ruby, JavaScript. Is it running? Yeah. Ruby, JavaScript, TypeScript, Python, Golang. And basically what it does is it generates this YAML schema of your data, which you'll see in a second, by analyzing your code. So what's really cool about this is it's not actually looking at your database. It's not like doing a table scan. It's pure static analysis by looking at the actual code in your code base. And the cool thing is what you can do is you can actually then use this in GitHub Actions. So every time you open a PR, what kind of data is it generating? Is the schema drifting or changing? And then basically flag potential issues before something goes out into prod. So we released the open source version, and I'll definitely share a link for that at the end as well. We've also built, of course, a hosted platform on top of this as well, where you kind of get this whole full-featured AI analytics engineer that can autonomously track all these analytics, monitor, kind of maintain your whole system. So kind of what you get with this is, first off, we built this UI where you can see all your events and properties. And for those of you who are familiar with the term like data catalog, that's basically what this is. Automatically filled in, always up to date. You don't need to manually fill it in. Really great for the non-technical users, so they don't have to, every time they have a question about, hey, what does this mean? They don't have to bug you. They can just go there. The other thing that we do is we continuously run an audit of your system. So opening a PR, breaking changes, if there's like inconsistencies with naming, we look at your site. We can even like recommend, hey, it looks like you're not tracking these links when you pushed out this new feature. And really most powerful of all is we have an AI agent that can really, again, answer a bunch of those pesky questions, but actually draft specs and write code. So now when you actually want to track a new feature, track a new type of data, it's easy to do that. So anyways, that's just been a little bit about Flisk. I definitely want to talk a little bit more about what's actually happening underneath to make all that possible, specifically with that open source project. And when we sort of had to approach, hey, we need to document all this tracking code, particularly inside Ruby, or really any language, kind of we're thinking about, okay, how do we approach this? And there's kind of the, hey, it's 2025, we use LLMs, right? Let's just put the entire code base into Gemini. You got a million context window, a token context window, right? Just throw it in there. And it does not work well. It ends up being very slow, hallucinates a lot. When you throw way too much at these LLMs, it just does not end up working as well as you'd think. So I was like, all right, this is not going to work. What's the next thing? Well, what we're tracking here are these very defined track calls, right? All these SDKs or functions, there's a specific pattern. Let's just write a crazy regex and try and parse all of that. And actually, that can get you a surprising amount of the way there. But the problem is one, especially when you get multi-million lines of code, giant code bases, it is actually not very performant to run a regex at scale. But also, there's all these other things. There are mutations of classes. There's inheritance. There's, you want to follow this chain of code to figure out how something works. A regex is not going to get you that. And so that is how we got to abstract syntax trees, for those of you who are familiar. So basically, for those of you who are familiar with compilers, transpilers, right? Basically what AST does is it breaks down your code base and it turns it into a tree. You'll probably see this in VS Code or any code editor, right? You'll see it'll kind of break down your code into functions and methods and modules and stuff. That's basically what's happening behind the scenes. And so, with this sort of tree-like representation of the syntactic kind of structure of your source code, we can use that to really analyze any code base, Ruby, Golang, TypeScript, whatever. So we sort of built this. But, we knew we wanted to use ASTs, but, when we first wrote Flisk, we started with JavaScript, TypeScript, because, where we saw the biggest need was for front end, hence, the NPM package that you guys saw earlier. But one of our customers asked us to, implement this on the Ruby on Rails backend. We needed to figure out how to do this quickly. And, I'll be honest, I am not a Rails developer. I had zero experience with Ruby until 3 months ago. So we're like, okay, how do we, again, go about this? And of course, again, it's 2025. We asked ChatGPT, right? So I'm like, hey, I literally gave it our NPM package, and I was like, can you convert it to Ruby? And it's actually did a surprisingly good job, I would say. It created this whole repo for us. But the thing that I realized as I actually started to dig into it is that, while it looked good at the surface level, I quickly realized it was missing a lot of things. It was only picking up the most basic cases. Again, there's so many just complex nuances with each language, with inheritance and modules and pointers and all these different things, that it ended up also just being clear. I needed to do a lot of Ruby-specific stuff, but there was also a lot of generic stuff that I need to be doing across all my languages. So I didn't really want to do a full port. And that is when I found Prism. So Prism is a parser. It was released to a good amount of fanfare last year. Rewritten completely in C instead of C Ruby, and really came out of the Shopify Ruby team. And the cool thing with this is because it was built with no dependencies, it also, critically for me, came with a JavaScript WebAssembly binding right out of the box, which was amazing. Because now I basically had this magic plugin that allowed me to use Prism for my Ruby code analysis that I could package into NPM. And basically what this ended up to look like is that, within my node runner, I can do all of the standard work that I do, but when I detect a Ruby file or a Ruby code base, I can then send it over to Prism, spins up WebAssembly, does all the parsing, and then I can get that back into JavaScript, which ended up being really, really awesome, and kept it all nice and clean. But yeah, that is all I have to share. Would really appreciate it if you guys, if you're interested, check us out on GitHub, give us a star on the repo, and if any of the stuff about like product analytics and just data tracking resonates with you, definitely sign up for our waitlist, or just come talk to me afterwards. Thanks.